Chapter 8, Section 10 in the 7th grade workbook is entitled Translations, Reflections, and Rotations. Let's go ahead and take a look at questions 1 and 2, where they're asking you to identify each type of transformation. Now, your three options are listed here in the title of the assignment. A translation is simply a slide of a figure, when you take and move a figure left, right, up, down, or some combination of those, with no other change to its aspect. Reflection is creating a mirror image of a figure, and usually that's done in one of three ways. We can reflect an image over the x-axis. If we take a look at number 2, we can cite an example here, taking and reflecting it over the line that runs left to right across the coordinate grid. We can take and reflect an image across the y-axis, reflecting it left to right across the coordinate grid, or we can do a diagonal reflection, which would be across the origin is what they would properly say, and that's really just a combination of the x and y reflection. Everything maintains its aspect here, just in terms of opposite. For instance, if something reflects across the x-axis and it's 2 units up, when I reflect it, it will then be 2 units down. It wouldn't, as a result, slide left or right. If I reflect it over the y-axis and it happens to be 3 units away from the y-axis to the right, when I reflect it, it will be 3 across from the y-axis to the left. And again, in this case, it wouldn't slide up or down. And then a rotation. A rotation is simply taking and turning an object. None of these three options here enlarge or shrink the size of the figure. That is the final type of geometric transformation, which is not in this section, known as a dilation. So since we've already made some marks on question number 2, let's go ahead and talk about number 2 there. All right, in number 2, as you can see here, what's happening is we have this fixed point. Right? Well, if I was just translating the shape, moving the shape, this top flat side would still be, no matter where it goes, the top of the triangle. And as you can see looking down here, it is no longer. It's actually the bottom of this triangle. So it cannot be a translation. Reflection would create a mirror image. Well, if we look at this point here on the flat side, it's 1, 2, 3 units north of the x-axis. That means when we reflect it, it would then have to be 3 south of the x-axis. And as you can see, that has not happened. So it's also not a reflection. That means this has to be a rotation. A rotation is when you take and turn an object, and not just turn an object, but you hinge it around a fixed point. So whatever point you fix isn't going to move, which is why the tippy top of this triangle is still on this same point in both triangles. So this here is a rotation. Now, as we go ahead and take a look at the next 2 questions, they're asking me to graph the translation. So what they're telling me here is they're going to slide the object, because that's all a translation is, it's the slide of an object. They're going to slide the object based on whatever specifications they give in the question, and you're going to draw the image, the after. What's already there is called the pre-image based on the definitions you've already seen in class. So in number 3, where they tell me to move the shape 5 left and 2 up, that means every corner is going to move 5 jumps to the left and 2 units up. And that's exactly all I'm going to do this. I'm going to take the point known as U and make 1, 2, 3, 4, 5 jumps to the left and 2 jumps up. And there's my new point. I'm going to take the point known as V and make 1, 2, 3, 4, 5 jumps to the left and 1, 2 jumps up. And there's my new V. And then I'm going to take the point known as T and make 1, 2, 3, 4, 5 jumps to the left and 2 units up. And there's my new T. I'm going to connect those points to draw my image triangle. Again, the after. This triangle over here is called the pre-image. Mark it accordingly, and I will have graphed the translation of the triangle shown in question number 3. In question 5 and 6, they're asking me to graph the reflection of each figure across the axis, and then they're asking me to write the coordinates of the vertices of each image. So after I reflect the image, they want to know at what point can I find each one of my new corners of the shape. So let's go ahead and take a look at question 5. Question 5, they're asking me to reflect the image over the x-axis. So that means they're asking me to reflect the image up-down. So if something is north of the image, it's now going to be south of the image. If something is south of the image, it's now going to move north of the image in the exact same amount as it is now. So for instance, if we look at point H is 1 to the north of the x-axis. So now instead it's going to be 1 to the south of the x-axis. Point J. Point J here is 1, 2, 3, 4 jumps south of the x-axis. So now it's just going to move 4 up, or 4 north of the x-axis. And then finally point K is 1, 2, 3, 4 units south of the x-axis, so it's also going to move 4 north of the x-axis. Notice none of these points that I've drawn have slid left to right. My H before and after are lined up north to south. My J's are still lined up north to south. My K's are still lined up going north to south. They have not slid left or right here in any way, shape, or form. They're just the opposite direction away from the x-axis. I connect my points. And I have my image reflection of the triangle. So now, as far as naming the coordinates here, where is point J? Well, point J is at -4, still on the x-axis because it has not slid left or right, and it's up here at 4 on the y-axis. So -4, 4. Remember, these little marks that I'm making here, that I made in 3 and that I've made in this question, indicate that these are the points on the image, the after. Point K, well, point K is still at 2 on the x-axis, but now it's also up here at 4 on the y-axis. Remember, we always write this coordinate first and then this coordinate second. And then the point known as H, the new H, is at -3 on the x-axis, I'm sorry, -5, -4, -5, -6, -5 on the x-axis, and -1 on the y-axis, so it's at -5, -1. Finally, we'll take a look at question 7. It says DEF has vertices at 0, 0, -2, -3, and -5, -3. Rotate DEF 90 degrees clockwise about the vertex D. Write the coordinates of the vertices of the image. So what they're asking me to do to start here is to sketch the triangle that has corners at 0, 0, which is right here, -2, -3, left 2 and down 3, and -5, -3, which means I'm going to go left 5 and also down 3. So as you can see, we have this obtuse triangle here. Remember, obtuse because it has an obtuse angle that we see down here. I'm going to go ahead and mark that that's the pre-image, just so I remember that that is the before. Okay, so now let's do what the question is asking me to do here. It's asking me to turn this triangle 90 degrees clockwise. So that means it's asking me to turn it moving that way, the same direction a clock moves. Everything is going to rotate 90 degrees. So 90 degrees is an L shape, as you know. So if something's pointing left, if I turn it 90 degrees, now it's going to point up. If something is pointing up, when I turn it 90 degrees clockwise, now it's going to be pointing to the right. If something is pointing to the right, when I turn it 90 degrees clockwise, now it's going to be pointing down. If something is pointing down, when I turn it 90 degrees clockwise, it's going to be pointing to the left. And notice each one of those turns that I've illustrated there represents an L-shaped turn, because an L-shaped turn is 90 degrees. So let's go ahead and let's go back and quickly label off this triangle here that we drew in red. I forgot that step, but not a big deal. Alright, now point D is always going to be right here. Why? Because they asked me to rotate the triangle about point D, meaning D is the fixed point, the point that's always going to be there. No matter how many degrees I turn it, D is right there. So if you want to picture me cutting out another triangle, laying it on top, I'm going to put a push pin through that corner marked as D. No matter how I turn it, that point marked as D is always going to still be there. Now, let's take a look here at EF, this line here on my triangle. EF is facing to the left. Well, if I turn it 90 degrees, as we saw from my illustration here, it's got to now be pointing towards up, because a 90-degree turn from left makes something go up. So, let's see here. Point E from D is 1, 2, 3 jumps away, and then 2 to the left. So when I make that turn 90 degrees, you know it's got to be going up, so I'm going to make it do the same thing. I'm going to make it go 3 jumps away now, and 2 up. And there's the new E point. Now maybe you're not seeing it yet. Let me keep going. You'll see it in a second here. As I go from my F point, from E to F, is 1, 2, 3 jumps. So as I draw my new F, I go 1, 2, 3 jumps. And then finish the triangle. Well, take a look now. Does it look like I've turned that triangle 90 degrees? Well, this E to F that was facing left is now facing up. Right? This one that was pointing kind of diagonal here, still the diagonal, has the same length, and a 90 degree turn. We'll look at these two sides. Let me go ahead and grab a little different color here or something for you so you can see these. You've got this side here and this side here. Well, just take a look. What shape do they make? Maybe I'll make it a little easier for you. Let me turn it like that. Notice there they make an L. Well, that means I had to have turned it 90 degrees. So there you go. There's my rotation. Now they're asking me to write the coordinates of the after, the image here. So D, still at 0, 0. The point known as E is now at negative 3, 2. And the point known as F is at negative 3, 5. And that's the coordinates of the image of the shape.